Yeah, what's up guys, welcome back to Trigonometry. Today we're looking at general solutions. I am Gaston Mapala right here at Maths with Gaston. I'm happy that you're joining us again so that we do these examples together. Remember, the aim is to get those level 7. I am an engineer by profession, vets graduate and also postgraduate with the distinction at University of Northwest. So welcome to my channel where we solely focus on pure mathematics, and then to make sure that you guys are able to do those serious courses that you guys want to do when you finish your mathematics. But for now, the focus is here, and then let's look at the first example that we have here is 2 cos 2 theta plus 7 sine theta plus 3. So now in this case, guys, what you want to do, because this is a general solution, first step, you must change everything to something that you can be easily to work with. So you will already see that we've got sine here, so we can't change this to cos. Remember, this we can see that needs to be changed because it is an identity. So therefore we rather change this to sine so that everything is into the same set of trig ratio that you want to work with. So now right here you're gonna come and say, okay, let's change this to 1 minus 2 sine squared theta, therefore plus 7 sine theta plus 3 is equals to 0. So therefore this should be easy to simplify. 1 plus 3 will give us 4, so you're gonna have negative 2 sine squared theta plus 7 sine theta plus 4. I hope you guys are following so far. So as you can see here, we want to deal with this properly, so we can't really do anything here. We can't take it a common factor because there's a 4 here standing alone. So the best thing that we can do here, we can multiply throughout by a negative. So we're going to multiply throughout by a negative 1. So therefore here is going to be 2 sine squared theta negative 7 sine theta minus 4 equals to 0. So guys, if you reach this point here, sometimes it's easy for some learners to see, sometimes it's not easy for some learners to see. You can see here you have reached a dead end. You can't take out a common factor, you can't do anything here. But guys, if I were to say let sine theta be equal to x, sine theta be equal to x, you would see that this quickly becomes a trinomial. Where there's a sine theta, we put x minus 4. So if I were to say to you factorize this, you will be able to factorize it, guys, because there's no sign here. So the best thing to do here, you can just come here and say, okay, can you do this in the exam in your answer sheet? Of course you can do this, guys. They won't penalize you for doing this. It's only fine because you have told them that you are letting sine theta be equal to x. I feel like when it's like this, it's much simpler and much easier to see for learners rather than when it's in terms of sine and cos, because it just becomes a little bit confusing for most of us. So now you can see, now here it is. Now you can come here and say put back sine. Therefore you would see that now you're gonna have 2 sine theta plus 1 as our factors here. Sine theta minus 4 is equal to 0. Therefore you can solve. Now you can say sine theta already taken is equals to negative half, or sine theta is equal to 4. Right, so now if you can see this one, if you go and say second function 4, it is going to give you an error. So therefore this is not applicable, or you can just write like that. So this one, where it is a half, remember now you've got a negative here. So normally I would tell my learners, when you do first second function, this will give you a reference angle. You can say second function 1/2 without the negative, guys. It will give you a reference angle of 30. It's going to give you a reference angle of 30, which is going to be K 360. So now you go to your cast diagram. Where is if you go to our cast diagram, I'm just gonna put it here. Where is sine negative? Sine is negative on the third quadrant and then the fourth quadrant. So therefore you are gonna come here and say, okay, our actual angle will therefore have to be, in the third quadrant we have got 360 or 160 rather, plus the reference angle, which is 30 in this case, plus K 360. This is on the third quadrant, okay, and therefore on the fourth quadrant we do have what? 360 minus the reference angle is equals to 360 minus the reference angle, which is 30, plus K 360. Therefore here theta will therefore have to be equal to 210 in this case, plus 360, and therefore the other one here will have to be 330 plus K 360. Right, and that's how you would deal with a question like this one that is asking you for a general solution. Okay, so I know you guys are thirsty for more examples. Let's go to the second one that you can see there on the top right. Okay, now this one here has got a cos here. I put them together on purpose so that you guys can see the difference between the two identities. The identities are still the same, but however, in this case here, look at me, I've put it x here, might as well, okay, let's just change this to theta, guys. This is theta, not x. Right, so therefore what you can do here in this case, you want to change this, but as remember what I said, you can't change it to sine because here you've got a cos, so you might as well change it to cos. So you're gonna change it to cos squared theta, cos squared theta, cos squared theta minus 1 minus 5 cos theta minus 2 is equal to 0. Therefore you group like terms here, cos squared theta minus 5 cos theta, negative 1 negative 2 will add up to negative 3 is equals to 0. When you get to this point, you can see, ladies and gentlemen, that you are stuck again, which means you have got a trinomial. So you are gonna let cos theta be equal to x, which will give you 2x squared minus 5x negative 3 close. Therefore you can now factorize this trinomial, which should be fairly easy. Two factors, when you multiply them together, they give you 3 is going to be 3 and 1, and then let me see, is it 3 and 1? Yes, it is 3 and 1, negative here plus over there. Great stuff. So what you can do now, you can substitute back and therefore say 2 cos theta plus 1, therefore close bracket cos theta minus 3 is equal to 0. So therefore what you want to do in this case, you can come here and say what you want to do, you can say, okay, therefore cos theta negative half, or cos theta, then take 3 to the other side. This one, if you were to take cos shift second function, is going to give you an error, so therefore there's no solution there, it's not applicable. Right, so on this one here, you can come and say, okay, therefore examiner, here's my reference angle here. I'm going to say shift cos. When you do shift cos, you are going to have 60 degrees here plus K 360. Now we go to our cast diagram before we start. Where is cos negative? Cos is negative on the second quadrant and the third quadrant. Therefore you come here and say, okay, no, this is the one on the second quadrant. We normally say 180 minus the reference angle on the second quadrant plus K 360. Guys, please I hope you understand where is this part coming from. On the second quadrant is 180 minus x, on the third is 180 plus x. This x here stands for reference angle. Okay, please don't get confused, guys. This x is for the reference angle. So now, and also now, finally on the third quadrant is going to be 180 plus 60 plus k 360. Okay, so therefore this one will give us 120 degrees plus k 360. And then therefore finally the last one here, 180 plus 60, will therefore give us an angle of 240 plus k 360. Right, and that's how you will deal with a question like this one. I am Gaston Mapala, guys. Please make sure that you stay tuned on this channel. If you're not subscribed, please do subscribe. I have helped a lot of learners to get distinctions. I'm also helping them, doing some tutoring on the side to make sure that we all understand this mathematics. So please give us a like, make sure that you subscribe. This is on our road to 10k subscribers. Please guys, give it a huge thumbs up. Would really appreciate, so that YouTube can recommend this video to many other learners. See you on the next one.